All right, let's get right into it. We're going to dive into this really fascinating new paper from NVIDIA Research, and it basically throws a wrench into one of the biggest assumptions in AI today. For the past few years, the whole vibe has been go big or go home. But what if the future of AI isn't about building these monster models, but something much, much smaller? This is going to be good. So let's just put the big question right on the table. Is the bigger is better era of AI actually coming to an end? This paper argues that for a huge, and I mean fast-growing part of the AI world, what we call AI agents, the answer is a pretty loud and clear yes.
So, here's how we're going to break this down. First, we'll talk about just how big AI agents have already become. Then, we'll look at why these giant models are currently king. After that, we'll get into the real meat of it, the case for going small. We'll even tackle the big counterarguments, and then wrap up with the paper's step-by-step guide for how the industry can actually make this happen.
Okay, first up, AI agents are not some sci-fi dream anymore. They are here, right now, and they are completely shaking up the business world. We're talking about AIs that are designed to do things for you, take actions, use tools, and knock out some pretty complex tasks.
And what's really mind-blowing here is the sheer speed of it all. This isn't some niche tech anymore. The surveys they cite in the paper show that over half, more than 50% of big IT companies are already using AI agents. And get this, a huge slice of them, 21%, just jumped on board in the last year. This is happening right now, and it is moving incredibly fast.
And this number, well, this shows you the massive economic engine that's driving all this. The market for what's being called Agentic AI is on track to be worth almost $200 billion in the next decade. And when that kind of money is involved, questions about efficiency and cost, they suddenly become extremely important.
So what's powering this multi-billion-dollar revolution? That takes us to the brains behind the whole operation. As of today, pretty much all of these agents are run by these enormous, general-purpose large language models, LLMs. Think about it like this. The way we do it now is like hiring a Nobel Prize-winning physicist who also happens to be a world-class concert pianist and a master chef, and then asking them to just add up some numbers on a spreadsheet. Most agents connect to this one, incredibly smart, cloud-based model for every single little thing they do. Sure, it's powerful, but man, is it overkill?
Now, to really get what this paper is arguing, we need to be clear on the terms. And they give us these two super practical definitions. An LLM, that's a model so huge it needs a whole data center to even run. But an SLM, a small language model, is nimble enough to run right on your home computer. That distinction, well, it changes everything.
And that brings us to the heart of the matter. Section 3, NVIDIA's big argument for a new era of AI, the era of the small. They're not just saying this is a nice idea, they are arguing that this is where we're all headed, that it's necessary and really inevitable.
And they don't beat around the bush. They put it out there with this incredibly direct statement. I'm going to read it because it's just so clear. They contend that SLMs are powerful enough, more suitable, and more economical. And because of those three things, they are the future. That's a really bold claim, so let's unpack it.
So first, point 1, are they actually powerful enough for the job? Well, the evidence is pretty stunning. You've got Microsoft's Phi models, which are just under 3 billion parameters, and they're holding their own against 30 billion parameter models on reasoning tasks. Then you've got a Salesforce model that's actually beating giants like GPT-4o at something called tool calling, which is really just the AI's ability to pick the right software tool for a job. The point is, for the narrow, specific tasks agents do, these small models aren't just good enough, they're often phenomenal.
Okay, now for the economical argument. And this is a jaw-dropper. The paper says that serving a request from a small 7 billion parameter model is anywhere from 10 to 30 times cheaper than using a giant 70 billion parameter model. That's not a small improvement. That completely changes the economics of AI.
And the benefits just keep piling up. Because they're small, they're faster, they use way less energy, and they're just more agile. You can train a little specialist model overnight, not in weeks. You can run them locally on your own machine, which is a massive win for speed and, importantly, for privacy. And at the end of the day, this basically democratizes AI. It lets more people build their own cool stuff, not just the tech giants.
Okay, so this all sounds amazing, but I know what you're thinking. There's a huge objection here, a big elephant in the room we have to talk about. By going small, aren't we giving up something really important?
Right? This is the question on everyone's mind.
Doesn't that ginormous size give the big LLMs a deeper, more general understanding of the world? You know, this kind of semantic hub that a small model just can't have? It's really the core of that bigger is always smarter idea.
So, the paper tackles this debate head-on. The counter-argument really leans on these things called scaling laws, which is just the proven idea that if you make a model bigger, it gets smarter. But the paper's rebuttal is smart. First, they say those laws don't really account for new, more efficient ways to build models. Second, and this is the key, agents usually break down big problems into tiny, simple steps, where all that deep general knowledge isn't even that useful. And finally, you can fine-tune a small model, give it some extra training on one specific thing until it becomes a world-class expert at just that.
So, if the case for small models holds up, how do we actually make the switch? That brings us to our last section, the practical game plan. Because the paper doesn't just throw out a theory, it gives us a clear, step-by-step algorithm for making this transition a reality.
And here it is. It's a 6-step plan that basically creates this awesome feedback loop. You start by just looking at the simple, repetitive stuff your big, expensive LLM is already doing. You find the patterns, and then you train a small, efficient SLM to be a total expert at just that one thing. You deploy it, you save a ton of money, you get more speed, and then you just repeat the process. You slowly replace the expensive generalist with a whole team of cheap, fast specialists.
And this isn't just theory either. The authors actually looked at some popular open-source agents to see how many of their calls to big LLMs could be swapped out right now. For MetaGPT, which acts like a little software company, they figured about 60% of the calls could be replaced. For Cradle, which is an agent that controls apps on your screen, it's a massive 70%. The bottom line is, a huge chunk of what these agents are doing is already perfect for this switch.
So what's the big takeaway from all this? The paper really paints a clear picture of what's next. Instead of one giant, all-powerful AI brain, we're moving toward more of a Lego-like system, an intelligence built from lots of small, super-efficient, specialized expert models all working together. It's all about scaling out, not just scaling up.
And that kind of leaves us with this final thought to chew on. Is the future of AI really about building one giant, all-knowing brain? Or is the smarter, more efficient, and maybe even more democratic future actually a smart swarm of many small specialized minds all working together? This paper definitely makes a pretty strong case for the swarm. Thanks for tuning in.